All right, example 3 says to solve the given triangle, if angle A is 123 degrees, side A is 47, and side C is 23. So I'm going to go ahead and set up my chart over here. I'm just going to leave the other side to actually do my work in. So I'm going to plug in what they gave me. And I notice that I have two sides and one angle. What are we going to do? We're going to look for a second triangle. So here's the thing basically, and you'll see as we're going to solve this, if I have to use the inverse sign button, there could be a second triangle. Alright, so what are we going to find first? Angle C. That's the only thing we can find, right? Because we know everything about A, and we only know side C, so we're going to find angle C. So we know, using the law of sines, that sine of 123 degrees over 47 is equal to, we don't know angle C, so just sine of angle C over side C, which is 23. Again, we're going to cross multiply with the numbers and divide by what's left. So sine of C will equal 23 times sine of 123 degrees all over 47. But remember, we're looking for angle C, right? So I need to switch these. And what is it called when I switch the input and the output?
The inverse.
The inverse. So to find angle C, we're actually going to take the inverse sign of that fraction there. So the 23 sine of 123 degrees over 47.
It's inverse
Because we're looking for the angle, we're going to use the inverse. Alright, so what did we find angle C to be? Alright, so let's go ahead and let's just round angles to the nearest tenth of a degree. Unless some reason the directions will tell us otherwise, okay? So sides to 3 decimal places, angles to 1. Unless the directions tell me different. Alright, so we got angle C is 24.2 degrees. Now, we know that 24.2 degrees is in what quadrant? Quadrant 1. And remember, I told you your calculator is going to give you that quadrant 1 angle. But you need to find that quadrant 2 angle. So how do we find that? Well, that's where the instructions above came from. Take 180 minus what we just found. So 24.2, which is
155.8.
All right. So that right there is a quadrant 2 angle, right? Now, so I'm saying if I have a second triangle, its angle C is going to be 155.8. Now, let's see, will that work? So then it told us to add the given angle. What was the angle that they gave us? 123 degrees? No, the other angle they gave us was angle A, which is 123 degrees. So we're going to add that in. Remember, the only way I can have a second triangle is if that number right there is less than 180 degrees. Is that? No, this is greater than 180 degrees, which means no second triangle. So we don't have to worry about on this one. There's only one angle that will, or one triangle, excuse me, that can be formed with the information that they gave us up there. So I don't have to make a second chart. And I know that this 24.2 degrees is what my angle C is going to be equal to. And then we just finish it off the same way we did before. The only difference between what we did in example 3 and what we did in 1 and 2 is we didn't have to look for a second triangle there because they'd already given us 2 angles. Alright, so what do you want to find next? Angle B? So we got 180 minus the other two added together. And so what is angle B? Good, 32.8 degrees. And then we get to find side B. And so I'm going to use the ones they gave me because I know that those numbers should be correct. So sine of 123 over 47 equals, we're after side B, so we need sine of 32.8 degrees over side B. So we're going to cross multiply our numbers and divide by what's left. So B is going to be equal to 47 times sine of 32.8 degrees over sine of 123 degrees. And so side B is approximately, round it to 3 decimal places. 30.358. Alright, so all my numbers are filled in. My angles have degree symbols. My sides don't have any units though, but did they give me units? No, so I don't have to worry about it. You can write units if you want to, but you don't have to for me. So there is the information for our triangle.
You want us just running our angles to the 10th? Is that what you were talking
Yeah, angles to the nearest tenth, sides to 3, nearest thousandths.